Okay, so let's go back to our definition here. We have that log base a of x equals k if and only if x equals a to the k. A is bigger than 0, it's not equal to 1, and k is a real number. So we're going to change exponents into logarithms and logarithms into exponential form. So let's start with example 5. Change each equation to its equivalent logarithmic form. So this is the way that I do it. I start with the base because I know that the base of my exponent is the same as the base of my log. So I know that this 3 in the exponent becomes a base 3 for my log. And then what do I do with my 2x and my 7? I'm just going to switch positions, right? So I dealt with the base first. The base of my exponent is the base of my log. And then I just switch positions for the 7 and the 2x. There's another way, if this isn't working for you, if this visual is confusing you, you can think about it as a to the k equals x. So you can kind of do a little circle here. A to the k equals x. A to the k equals x. Lots of different ways to memorize this definition. But we're going to use this definition on like 90% of the problems that we solve. So it's going to be very important that you know this definition. So example 6 says change each equation to its equivalent exponential form. So now I want to take these logs and I want to write them in this form, in this exponent form. And I know that the base of my log is going to be the base of my exponent. And then I can just switch those out. So the answer to my log is the exponent. So 4 to the third equals 5 plus x. So what about part B, log of x equals 3? So I have to think about this one because I don't see a base written. So if there's not a base written, what number goes there? Good. So remember, log of x is the same as log base 10 of x. So here, this nothing there tells me that my base is going to be 10. And then I just need to what? Switch the 3 and the x. My equal sign comes straight down. So C is the natural log of x equals 3. So now I have to think about this one because this one doesn't have a base either. So whenever I see this ln(x), what is my base? So remember, natural log of x is the same thing as log base e of x. So this tells me that my base is an e. Whenever I see the ln, my base is an e. And then I just switch my x and my 3. We're going to start solving exponential equations now. So example 7 says solve 10 to the x equals 33. And we're going to approximate the exact answers to the nearest hundredth when appropriate. Whenever we have an unknown value in the exponent, we should be thinking, I'm going to deal with logs in this problem. Whenever your unknown is the exponent or part of the exponent, you're going to have to work with logs. Well, since we need tables or calculators to work with logs, we know that we're going to be doing a lot of rounding, which means we're going to be giving approximate answers instead of exact answers. The exact answer would actually be in the log form, but once we put it into our calculator, we're going to get an approximate answer. So we're going to learn 2 strategies for solving equations like this. So strategy 1, because the variable, the exponent, we're going to change the equation to its equivalent logarithmic form. So we're just going to use the definition. So we're going to do exactly what we did on the previous problem in this first step. So how do I write this as a logarithm? So the base of my exponent is 10, which means what? The base of my log needs to be 10. And then I'm just going to crisscross and switch my x and my 33. But notice, this makes all x all by itself now. How convenient is that? Because that's what we were trying to solve for. So just applying this definition solved for x. And now we just have to put log of 33 in our calculator. So go ahead and put in log of 33 and round to the nearest hundredth, which is 2 decimal places. What do you get? So notice that this 10 is just going to drop down, and that's going to give me my common log, but we usually don't write that 10 there. But this is going to be the common log, and then we're going to switch our x and our 33. And we put that into our calculator, and you should get approximately 1.52. Look at our second strategy. Our second strategy is going to be more similar to what we're used to with solving equations. So, for example, if you were saying x plus 5 equals 10, if you were trying to solve that, your plus 5, you would undo that by subtracting 5 from both sides, right? So you would undo the addition by subtracting. If you had a problem that involved multiplication, you would undo that multiplication by dividing both sides by the same non-zero number. If we were squaring something, then you would do what? You would take the square root of both sides of the equation, keeping it balanced, but doing the inverse operation to both sides. So strategy 2 is just that. So because the variable is in the exponent and the base is 10, we could take the common log of both sides here. Now, we're going to use this property log base a of a to the x equals x to simplify. So it's going to be important that whatever the exponent base is, that needs to be the base of your log when you take the log of both sides. So let's do it this way. We're going to take the log of both sides. So 10 to the x equals 33. So I'm just going to take the log of both sides. So I have to keep my equation balanced. So I just do log of 10x on the left, log of 33 on the right. But notice when we simplify this, this is log base 10 of 10 to the x. Well, if the base of the log and the base of the exponent are the same, then this expression on the left-hand side will just simplify to what? Just x because of this property. So this would be x is approximately 1.52. Again, putting the log of 33 into my calculator. So the left-hand side simplifies to x, and this right-hand side approximates to 1.52. So we have 2 strategies that I just gave you. So today, we're going to focus on this first strategy. But either one will work. And I will tell you, 95% of the problems that you'll see in this class, you can solve by using strategy 1, just by using the definition. And it's usually shorter to just use the definition.